All right, good evening. Welcome back to Pre-Calculus with Trigonometry. So we are going to be looking at 4.4 here, problem number 4. So let's see. We have a point is given on the terminal side of the angle, drawn in standard position. Find the values of the 6 trigonometric equations or trigonometric functions and simplify your answer as much as possible. All right, so we get to draw something. Okay, so the first thing we got to do is we got to figure out, okay, where is the point 5, negative 12? Okay, so 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2. So down here somewhere, 5 down here. Okay, so this is 5 and then negative 12. Sorry for the writing. Let's change this back to blue or something. So you have to worry about that. So technically, the angle we're looking for is this guy right here. Okay, but we can also look at this triangle kind of in blue, where this is a negative 12 height here, and this is 5 over. So we could really just look at the reference angle. So remember, the reference angle always goes to the nearest horizontal. Okay, so technically we could look at this angle right here. That's a phi. It's this symbol. Okay, this is a phi. Okay. So when we talk about finding the sine of theta, which is this whole deal here, this is also going to equal the sine of phi, so that's our reference angle. That's what we use reference angles for, rather than trying to figure out this horrible triangle all the way around. Okay, I'm sorry, I shouldn't include this part. Just this part here. Okay, but that doesn't look like too much fun. So let's take the smaller triangle, cute triangle. Say, well, this is the opposite value. It's negative 12. And then we have to figure out what's this distance here. Okay, what's the hypotenuse? So we have a squared plus b squared is equal to c squared. I hope that isn't a surprise. Okay, so we're going to have 5 squared plus 12 squared is equal to c squared. 25 plus 144 is equal to, looks like 169 c squared. So c would be 13. So this value here, this hypotenuse would be 13. So this would be negative 12 over 13. So sine is negative 12 over 13. Okay. Now that we have our values here, okay, let's have quadrant 4. So we know the cosine. All students take calculus. So the cosine is positive. So that's 5 over 13. 5 over 13. 5, 13. Okay, and the tangent is opposite over adjacent, so that's negative 12 fifths. Okay, so we're going to get negative 12 over 5. Okay, and then going through and just kind of going through the rest of this. Cosecant is the reciprocal of the sine, so that's going to be negative 13 over 12. So we have negative 13 over 12. Secant is a reciprocal of the cosine, so it's going to be 13 fifths. 13 over 5. And cotangent is reciprocal of tangent rather, so it's going to be negative 5 twelfths. So it's going to be negative 5 over 12. Okay. Hooray. Okay, we're good. Okay, and we'll move on. Oops, I just want to say continue. And yes, I realize that there are just a lot of problems, but honestly, it's just one of those things where the more you do of this, the more familiar this will become, so you won't have to worry about it. But sine again, or what's cosine again, you really don't want to be in that position. So let's go with this one. This is given the point on the terminal side here. 6 trigonometric functions for 5, negative 6. Okay, so where's 5, negative 6? So that's 2, 3, 4, 5. 5, 6. 5, 6. So we're down here. This is 5, negative 6 is this point here. So what we're really looking for is this angle right here. This is our reference angle. This is really what we're going to use for this. So we have an adjacent side of 5, opposite side of 6, negative 6 really, and we need to figure out what's our hypotenuse here. So c squared is equal to a squared, 5 squared, plus 6 squared, technically negative 6 squared, but once you square it, it's going to be, positive number. Add that together, and that looks like, where's that going to be? It's going to be a 41 or something. So that's equal to c squared. So c would be square root of 41. Okay, assuming my arithmetic is good. Okay, so really what we have here is we have this triangle here. Okay, we have 5, negative 6, root 41 from this angle. So we're going to be looking at, at this angle based off of this point of view. Okay, this is my eye from physics or from satellite. Okay, so we'll just go through and say that. Okay, so that sine value here, sine of theta is equal to negative 6 over root 41. Oh, but we want to rationalize the denominator. Okay, so again, I apologize. I know this is not a 20th century skill. You guys have calculators that will do this, and it won't be a big deal. But most of the textbooks were written by people my age, and we were raised where we had to rationalize denominators. So this actually goes back 2 generations. So this one, you can't fault boomers for this one. Okay, so we go ahead and do this. 41 root 41. Okay, so this is negative 6 root 41 all over 41. We'll just rationalize the denominator. It's not the worst thing. Okay, so there we go. So we have sine is going to be, we have negative 6 root 41. So we have negative 6 root 41. Let's get out of the radical, divided by 41. And that's going to be our value there. Okay, cosine. Okay, that's going to be 5. In this case, it's just positive. 5 root 41. That's my cosine. It's adjacent over hypotenuse. So root 41. Root 41, just multiplied by 1. So this is 5 root 41 divided by 41. Okay, so that's all right. Even Christian makes for this too. That's fine. Okay, so that's 5 because we're still writing the books. So 5 root 41 and then divided by 41. Okay, so there we go. Then we have to do tangent. So we'll go back to our triangle for tangent, opposite over adjacent. That looks like negative 6/5. So tangent of this angle is equal to negative 6 over 5. We don't have to rationalize. 5 is a rational number, so negative 6 over 3 over 5. Okay. Oh, that's not cosecant. I want a tangent. This is negative 6 over 5. Okay, and now for the cosecant, right? Our cosecant. Well, in this case, we don't have to rationalize the numerator. Let's get rid of this. This is not true. Okay. Can I please backspace out of this? Thank you. Okay, so cosine. Let's go back to our triangle. What am I doing? I erased the wrong one. So that's 5 root 41. 5 root 41 divided by 41, 6/5. Okay, cosecant, that's what we're looking for. That is root 41 over the opposite. So root 41 over negative 6. So we have negative root 41 over 6. Now the negative is on the outside, not the inside. Okay, so be careful about that. That's cosecant. Secant is the reciprocal of cosine, so that's root 41 over 5. So here we're going to have root 41 over 5. And then cotangent is finally there. We have cotangent that's going to be negative 5/6. Negative 5/6. Okay. So we'll check. My fingers are crossed. Hopefully I typed these in correctly. What did I not do correctly? I didn't do a lot of these correctly. Oh, they don't like this at all. Okay, we're going to recheck and recheck so I can see what the heck's going on here. Did I not? 25 plus 31. Let's double check. Okay. 25 plus 36. Yeah. Oh, 61. Ah, that'll do it. Okay, let's fix that. Okay. So we're gonna have 61 here instead. You guys probably caught that already. Okay, that was 61. Here we're gonna change to 61 over root 61. All right. This one was fine. This is just root 61. And then this was root 61. Okay. So if you caught that, good deal. All right, now that still don't like it. What did I do wrong? Gotta check it right. There it goes. Okay, now I've checked it. Okay, just be more careful with the arithmetic. You should probably all be more careful with arithmetic, but me in particular. Okay, so that's how you do a problem like that. It's not really how you do a problem like that. You should do it better. Okay, sketch negative 30 degrees in a standard position. Negative 30 degrees, we're going to grab this piece here. Negative 30 degrees, that seems to be approximating it. I'm not going to worry too much about getting this correct, mostly because to do this properly, we would need a protractor or something like that. It looks like what we have 10, 20, yeah, dividing up into 4 spaces. So I'm just kind of approximating this to double check it. But and then it show its reference angle. So we're going to hit the reference angle, and this is the reference angle. Okay, and we'll see about both of those. Okay, I'm not going to guarantee anybody's going to be correct here, but we were. Okay, that's all they want us to do for that. Okay, again, reference angle goes from whatever you have to the nearest horizontal. Okay. So reference angle for negative 60 degrees. Where the heck is negative 60 degrees? It's going to be the same kind of problem we just did. Okay, so negative 60 degrees is going to look like this. Here's negative 60. How do we get to the nearest horizontal? Just doing that. And that's just 60 degrees. So negative 60 degrees or 60 degrees would be the reference angle. So we're just going to go ahead and say 60. It's not always the same. It's just when they're in the fourth quadrant like this, they happen to be the same. Okay, the negative and the positive are the same idea. Okay. And I guarantee you, you will run into more problems with reference angles because that's just how this works. Okay, 690 in standard position. So, oh boy, 690 in standard position. So let's figure this out. So we are going to need a calculator for actually not a calculator, but is it positive or negative? Looks like it's positive. So 690 degrees. So that's at least once around a circle. So if we go around a circle once, it's minus 360. So it's 0. It's going to be a 3. It's going to be a 330 degrees. So what we're going to do is we're going to go around the circle one time. That's a 360. Okay, we're not done yet. We got to go around another 330 degrees here. Okay, so we got to go around. There's 90, 180, 270. Come on, keep going. And then 3. I think this will be 330. This 360 is very close to 330. Okay, and then our reference angle is just going to be square right here. And so that's our reference angle. It's going from here to the nearest horizontal. Okay, and all this is telling you is we went around the wheel a couple of times before we decided to stop. That's all we're doing. Okay, that's all they want us to do for that. Okay, so I'll go ahead and stop here, and then we'll continue and do some more. Okay, so what is this? This goes up to number 8. So thank you for tuning in. I will see you in the next video.